Okay, today we're going to go over reading a graph. Before we start analyzing a graph, let's go ahead and go over some basic parent functions for this unit. So the first one is a constant function, so that's going to be y equals any number. Okay, and notice that there is not an x attached to that number. It could just be like y equals 3 or y equals 4. So when you have an equation like this, it is going to be a horizontal line on your graph. Okay, next one is a linear function. So if I give you y equals x, notice that the exponent on your x is always going to be a 1, so it can't be x squared or x cubed. It just has to be x to the first power. That's going to make it a linear function, okay, which is just a straight line. Okay, and then the last one is your absolute value function. So remember that absolute value functions have the shape of a V. Okay, so now let's go ahead and analyze our graph. So when we're answering these questions, we want to make sure that we're using interval notation whenever possible. Okay, so the first question says, is the relation a function? So if you remember from the last video, when you're looking at a graph, to determine if something is a function, we need to ask ourselves, does it pass the vertical line test? Okay, so if we were to take our pencil and move it along our graph, it never touches the graph in more than one place, so we can go ahead and say that, yes, this is a function. Okay, the next question is asking whether this function is even or odd. So remember, the easiest way to determine this is to pick a point on your graph. So I'm going to pick this point here, 2, 8. Okay, so remember that if it's an even function, that means that your x value is going to become negative, but the y value will stay the same. Okay, if it's an odd function, that means that the signs on both your x and your y value are going to be the opposite. Okay, so now I'm going to check to see if either of these points are on my graph. So if I look for -2, 8, that is a point on our graph. And even looking at this, we can see that this graph is symmetric about the y-axis. So that lets me know that this is going to be an even function. Okay, and then now looking for the x-intercepts. So we're looking for all of the ordered pairs where our graph crosses the x-axis. So I can see 3 of them. So we have the points -3.50. We have the origin 0, 0. And we have 3.50. Okay, next we're looking for where does our graph cross the y-axis. So the only place where our graph crosses the y-axis is going to be at 0, 0. Okay, the next one is asking for the maximum. So when you think about the maximum, you want to think about what is the highest y value. So if I look on my graph, the highest y value is going to be at these 2 points here. So that has a y value of 9. Okay, and notice that we hit that maximum twice. So that's going to be at the x value of -2.5. And at positive 2.5. Okay, so now they're asking us for the exact opposite. So now instead of the highest value, we're looking for the minimum. So we're looking for the lowest value. And notice that this is a little different because it gives us this keyword here that says relative. So when you see the word relative, that means that if we're looking at this graph, notice that it keeps extending downwards. So technically, we don't know what the minimum is. When they say the word relative, they're specifically looking at a section of your graph. So looking at this portion of our graph, what would the minimum be? Okay, so again, we're ignoring that this graph continues downwards. The lowest point in our graph is going to be right here at the origin at 0. Okay, so the minimum is going to have a y value of 0 when x equals 0. Okay, so now we have increasing and decreasing. So when you're thinking about increasing, that means that as your x values are getting bigger, your y values are getting bigger as well. So the easiest way to approach these is that you want to look for this portion of your graph. So if you think about a linear function, if you were to draw a line along your graph, it would be going uphill. So if I look at my graph, if I draw lines along my graph, so my line is going uphill over here and over here. Okay, so I'm going to highlight these sections as increasing. Okay, because that's where we have those lines that are going uphill. Okay, so now looking at those portions that I highlighted, that's where we want to write those sections in interval notation. So when you're writing these increasing and decreasing intervals, you're only concerned with writing your interval notation in terms of the x values. Okay, so you're never looking at the y values. So if I look at this first portion over here, so notice that my graph keeps extending. So if I think about it in terms of the x values, it's approaching all of these negative x values. So we don't know what the lowest x value is. We just know that that number is negative. So we're going to start with negative infinity. Okay, if I keep moving along my graph, okay, this is where we stop increasing. So that's going to be at an x value of negative 2.5. Okay, and we're going to have parentheses on both of these because if you look at this point here, you're not only increasing, but you're also decreasing. So since we're changing directions at that point, we're not able to include a bracket on it. It has to stay a parentheses because it's doing two different things at that point. It's both increasing and decreasing. Okay, so now going to our next highlighted portion. So we start increasing at an x value of 0. Okay, if I keep following my graph, I stop increasing at this turning point here, which has an x value of 2.5. Okay, and again, make sure that you put parentheses on here because this is a turning point. We're both increasing and decreasing at that point. Okay, the last thing that we need is to include a union to join these interval notations together. Okay, so decreasing is the exact opposite. So if I were to draw a line along my curve, notice that this line is going downhill. So that means that our graph is decreasing. Okay, so I'm going to go ahead and highlight those portions. So again, just like we did for increasing, we're going to write those sections of our graph in interval notation. Okay, so again, you want to think about it in terms of the x values. So if I start at this green section, I start decreasing at an x value of negative 2.5. Okay, I stop decreasing at an x value of 0. Okay, going ahead and writing the second part. I start decreasing at an x value of 2.5. Okay, and notice that our graph keeps extending. So if you think about it in terms of the x values, these x values on the right-hand side are positive x values. So that means that we're going to be approaching positive infinity. Okay, so make sure that you're not confusing it with the y values. Okay, so now let's go ahead and look at the next part of our graph. Okay, so remember from the last video, when you see the word fx, that means that they're really asking about the y values. So this is saying when are our y values greater than 0? So when is our graph above the x-axis? So let's go ahead and highlight that portion. Okay, so here's where our graph is above the x-axis. So we need to write this in interval notation. And if you look carefully, it says that we're greater than 0. So that means that when I'm writing my interval notation, I can't include things that are equal to 0. So I'll show you how we're going to handle that. Okay, so I'm just going to make a point here because this is where we're exactly 0. So we're going to need to do a little break in our interval notations. So the first thing that I'm going to do is I'm going to write the interval notation for this section here. Okay, so again, just like with increasing and decreasing, you want to think about it in terms of your x values. So here I'm starting at an x value of negative 3.5. Okay, I keep on going along my graph and I stop here at 0. Okay, so again, I have to stop here and include a parentheses because it only says greater than, it doesn't say equal to. Okay, now we're going to write the second part of our interval. So I start at 0. Okay, keep following my graph. I stop being above the x-axis at an x value of 3.5. Okay, now let's do the opposite. So when is our graph below the x-axis? So that's going to be in these regions here. Okay, so again, we're thinking about it in terms of x values. So if I look at my graph, thinking about the x values, I know that all of these numbers are negative x values. So I know that I start at negative infinity. Okay, I keep on going until I hit the x-axis, which is a value of negative 3.5. Okay, going to the next section. So I start being below the x-axis at an x value of 3.5. Okay, my graph keeps extending. It's extending towards all of these positive x values, so it's approaching positive infinity. So again, everything here has parentheses because again, there's multiple things that are happening. At this point, we're both above and below the x-axis. Okay, for the next one, so looking at f of negative 2, so this is your x value, because if you look back at your function notation, your x value is always in parentheses. So if I find negative 2 on my graph, so here's where x is negative 2. I'm going to move up to where I hit my graph, which is right here. Okay, if I go to that point, that has a y value of positive 8. Okay, so now let's look at the opposite. It says when f of x equals negative 1, what is our x value? So again, if you want to think about it differently, they're saying when your y value is negative 1, what is your x value? Okay, so I'm going to erase some of this. Okay, so looking at my graph, so here's where my y value is negative 1. Okay, so here's where it intersects my graph. So that intersects my graph at negative 3.5. And it also intersects my graph at positive 3.5. Okay, last part is domain and range. Okay, so remember from the last video that when we're thinking about domain, we're thinking about all of the possible x values that our graph can have. So if you look at our graph, notice that it's extending in both directions. So eventually it's going to hit all of the negative x values and all of the positive x values. Okay, there isn't a value that is being excluded. So that means that our domain is going to be negative infinity to positive infinity. Okay, we can have any number that we can have every single number possible. Okay, for the range, you're thinking about all of the y values. So we want to go from the lowest to the highest y value. So again, looking at our graph, it keeps extending downwards. We don't know the lowest y value, but we know it's negative. Highest y value is going to be 9.